Hello, everybody. Hello, everybody, and welcome to our session on communicating uncertainty among scientists to policymakers and the public. My name is Jill Tudor. I'm Chief of Public Information at the CTBTO, and I'm here with my colleague Mario Zampolli, who is from the International Monitoring System Division. And we are here to convene, and then we'll be handing over to our esteemed speakers and our moderator. Just to put this session in a little bit of context, there's a common misconception among non-scientists that science provides certainty. There's only one answer to 2 + 2, and that's always going to be 4. And if somebody says it's 5, we say, you're wrong. But scientists know very well that uncertainty affects every measurement, and it affects every scientific statement. There is no such thing as absolute certainty. So the question is how to square this circle when scientists are speaking to non-scientists, when policy or important personal decisions might be resting on the basis of scientific evidence. We only have to look, for example, at the issues of climate change, COVID-19, to see that this is a very, very topical issue. And the risk, of course, is that the public perception of this uncertainty, if it's not communicated in the right way, can actually undermine the perceived credibility of the scientific arguments that are being made. So this is a really crucial question. How can scientists communicate on these uncertainties and put them into the right perspective clearly and effectively so that they can support good policy and they can support well-considered personal decisions?
Thank you, Jill. So without further ado, I would just like to introduce briefly the moderator and our distinguished speakers. The moderator is Peter Rickwood, a journalist with a long-standing experience in nuclear matters and founder of Atomic Reporters and a very close collaboration and friend of CTBTO. James Gillis, who is a particle physicist and senior communications advisor at CERN, the particle accelerator in Geneva, Switzerland. Angela May, who is the chief of research and trend analysis branch at the United Nations Office on Drug and Crime. Nima Arora, who is the founder of Bayesian Logic Inc. in Berkeley, which is, and he's the inventor of a tool which is called NetVisa, a Bayesian machine learning tool for seismoacoustic automatic event association that has been introduced to CTBTO operations. And he is one of the people for whom uncertainty is really part of the core business. And the same goes for the other panelist, Syed Mekaimer from the National Data Center, the National Institute of Astronomy and Geophysics in Cairo, Egypt, who is an expert on the application of Bayesian inference approaches to address the uncertainty in radionuclide source term estimation. So please, at this point, Peter, we give the floor to you and to our distinguished panelists. Thank you.
Good morning, everybody. Pleasure being here. I hope it's a pleasure for our audience as well. My perspective is that of a journalist, so I'm feeling a little bit awed by such a group of experts, because journalists are dilettantes, we're not experts. However, journalists have to deal with a certain rigor. One of the challenges that we are presented with is, if your mother says she loves you, check it. But we're not very good with uncertainty. And I'm just going to illustrate that by commenting on my past as an environmental reporter when I was covering toxic chemicals in the Great Lakes, among which was TCDD 2472, I beg your pardon, 2378, the dioxin. I'm sure we've all heard of Agent Orange, terrible chemical. And I was trying to follow up these stories, and on one occasion I went to my editor and I said, "Come on, we've got to do more on this. We're not informing the public." And he said, "Show me the bodies." So uncertainty is anathema, and I think we also have to accept that human brains, probably hate ambiguity. So it's not an easy challenge to take on. Nevertheless, our panelists, I'm sure, are going to inform us and explain how they meet this challenge. And I think it would be great if we could first hear, please, from Angela, who I know has had a lot of experience and probably frustration. Thank you, Angela.
Thank you, Peter. And well, first of all, I feel a little bit intimidated with all of this physical scientists. I'm a social scientist, and so what I would say is about the communication of uncertainty when we talk about the social science phenomenon. And in my role in leading the research on drugs and crime, I wanted to bring you particularly two examples to make a point. And my point is that what I notice in my job when we have to communicate research findings, particularly when these research findings are very sensitive, like the drug sphere, as you probably all know, the drugs policy is very polarized. And so everything you say, somebody is waiting so that you can camp on one side or the other. So what I notice is that often is not only the way how we communicate, but also the way how we help the policymakers and journalists, Peter, to deal with uncertainty. And I want to bring you two examples. So one example is at a certain point, one of the basic indicators that we have at international level on drugs is the number of people who use drugs. And that's again is used, if it's going too much, some may consider that then the drug policy doesn't work. If it is stable, then in a way others may say, you see, drug policy work. So it's very sensitive. So, but at a certain point, clearly the data that we have is very weak. And so we cannot really say with the data that we have whether year by year there has been a change. So what we did is that we said we start publishing only intervals, ranges, something that we can comfortably say, and then we say from now on we will only publish ranges. Well, what we notice is that everybody, and the media is first, Peter, what they did, they just took the midpoint. So to me, to conclude that the world out there was not ready to handle uncertainty in terms of, for example, in this case of the indicator on drug use. So I think as a scientist, we need also to help our constituencies to also see how to handle uncertainty and how to use uncertainty. But also, as a scientist, we also need to understand that if we always say our findings needs to be used for policymakers. We do all of this fantastic job because we expect someone to take decisions based on our results. So we also have to be understandable that making decision is difficult if you say, I don't know. And I bring here another example that shows again the point of how also policymaking needs to adapt and to deal with uncertainty. We have one of our role is to monitor the cultivation and production of drugs, and so particularly through satellite images we monitor the production of opium. And our data, particularly on certain provinces in certain countries, they're linked to funding. So if a province stays below a certain number of hectares, the provinces receive millions of dollars because in a way they are doing good performance. And so 1 year again, we realized that our sampling approach, and you all know, it has such a high variability that we didn't feel comfortable to say, and we wanted to tell the policymakers, look, our methodology cannot differentiate for these provinces the threshold that you are looking for. The donors and the policymaker again could not handle it. And basically the message that we received was we need to take a decision. And so we expect you scientists, we understand that, may not be, but we wanted to, from you, what is the best that can help us to take decisions. So I just wanted to, conclude by just saying that we also need, I mean, our role is definitely always to communicate, to be transparent. And over the year, we have developed a lot of visualization methods also that shows the blur around the figures. But at a certain point, we also need to appreciate and also to help policymakers to understand, first of all, how to read uncertainty, but also to help them to adjust and to understand how they can take decisions when data are based on uncertainty. So back to you, Peter.
Angela, that was fascinating, and I don't know. Sometimes it seems to me we have to have a completely new language, but that's unrealistic. You mentioned funding, and if I could just jump to James for a moment, please, because obviously there's been a huge amount of money invested into your project, which of course is overshadowed completely by uncertainty, by probability. I just wonder how you justify to funders who are usually fairly hard-nosed, a research project of the the size of CERN.
Well, first of all, I mean, the amount of money that goes into CERN is big. There's no denying that. We have an annual budget of 1 billion Swiss francs per year. But in the global scheme of things, it's relatively modest. And a particle physicist in Europe costs about the same as a biologist in Europe. It's just that we focus it on big facilities in places like CERN. So to the answer to your question, I mean, I'll start with a little historical angle to it, that CERN was established. The first idea that you might create a CERN was put forward to the United Nations in 1946 as science being a neutral language which would bring a warring continent together. So CERN was created as a place to do fundamental physics, nuclear physics. Do nuclear physics anymore? Hardly at all, because the field that we're involved with now is called particle physics, and it didn't exist when we started. But fundamental research, and also a place where people could collaborate peacefully together. So we have fulfilled those missions. Our main mission today is fundamental research, but more and more we are indeed asked to justify our existence on the basis of what we deliver to society. And I'm getting very off topic here, I'm aware, and I'll come back to the subject in a while, but we can demonstrate that there are many examples of technologies developed in the name of basic science, because you've got a lot of very smart people who want to understand the universe, who don't understand the word impossible, and if they need a piece of kit that doesn't exist, they go and make it. So one of the things that we can, well, the World Wide Web, of course, is the best known thing that came out of CERN, but there's a lot of contributions to medical imaging and so on and so forth. But I will move on and get back to the subject, because what everybody said so far really resonates, and it's become clear to me. I started off as a research physicist, but I haven't been involved with research for the best part of 30 years. I've been involved in communicating science. And what I've come to think, and what I've actually said to my colleagues in physics, is I really don't care if people understand what the Higgs boson is, but what I want them to do is first of all think that finding the Higgs boson is worthwhile for humanity to do, but most importantly, more importantly than anything, is to understand the power of evidence-based decision making. So as a science communicator, I think that our job is to portray the process of science. As somebody who's grown up and lived science all their life, it is just, to me, it's natural that if I have to make a decision, then I see what the evidence is. If I need to get vaccinated, I look at the evidence, and there's no question I'm going to get vaccinated against COVID-19, for example. I'm aware that if I walk out into the street, it's more dangerous than taking a plane flight and things like this. But most people don't think that way. Most people are looking at science, as everybody said, for certainty. So as a science communicator, I think it's really our job to show the power of evidence-based decision making, how it works, and also how science works. The thrill of science as well is very important. So that's it. And I think that became particularly clear. I mean, I think the reason I'm on this panel is I've been at CERN. I was head of comms from 2003 to 2015, and that was a period of time in which we had to deal with works of fiction from authors like Dan Brown and Robert Harris saying that CERN is dangerous and physicists are dangerous and so on. We had to deal with people who apparently had the credentials to be authoritative, saying CERN is going to create a black hole that will swallow the planet, and things like this. And I will give you one example of something that we did and worked. Actually, I was very pleased that it worked. But at one point there was somebody blogging, somebody who obviously understood science blogging, and they said that if if they manage to shut down the Large Hadron Collider, we'd better ban wardrobes because I don't want my children ending up in Narnia. Right, and the references to The Lion, the Witch, and the Wardrobe, where the kids go into the wardrobe and they find another world universe behind it. So what we did was we sort of thought, okay, let's do a risk analysis, a comparative risk analysis between running the LHC for 25 years and opening a wardrobe door once. And so we because the basis of the kind of science we do is that you can never be certain of anything, even if you open a wardrobe door 1,000,000 times. The presence of Narnia might be an extraordinarily rare event. So the 1,000,001st time you might find yourself there. So we sort of did some rough analysis of when wardrobes were invented, how many they've been, how long they last before the doors fall off, and we made a very important assumption that nobody has ever ended up in Narnia. Certainly we don't know of that. And we worked out that running the LHC for 25 years is about 10,000 times safer than opening a wardrobe door once. And we used that. And what we found is that people engaged with it. So for me, another important message is that it's important to treat audiences as intelligent. And if you do, then they respond to you in an intelligent way. So don't patronize your audiences is basically an important message from me, from my experience.
That's great, James. Thank you very much. I'm getting worried about the wardrobe in the next room.
Yes.
Syed, can we just turn to you because a question for me again with this sort of thick journalist mind of mine is how do you explain to the public the importance of the research that you're undertaking? How can you justify it? Why aren't you out there, digging holes in the ground and planting things? What is given the nature of science, as we know, that it's riddled with uncertainty and we can't guarantee results. How do you explain to people who have a much different view of their lives the importance of what you're doing? Over to you, please. Syed, can you hear me?
Oh, you can hear me? So if I understand your questions well, you ask how you can interpret the uncertainty to public and public audience and policymaker. This is true. I have a problem in the speaker and I change my computer. So if I repeat it, if I don't hear it in correct way.
No, Syed, that's fine. You got me right. What I'm trying to do is to just get behind the issues that you as a scientist are dealing with, and trying to find out how, in terms of communicating with the public, you would explain the work you're doing, its importance, and why it has to go on. Because I think a lot of times, particularly in the current day and age, science is getting dismissed. Experts are getting dismissed. So, how do you address this dilemma?
Okay. I heard the questions. I hope that I heard them in correct way. As a meteorologist, we deal with uncertainty in many areas. The uncertainty in atmospheric science is the inherent part of in observation, in modeling. The science based on two pillars: the observation and modeling. I mean by modeling, conceptual model, theory, simulations. Both of them have uncertainty, and we deal with a system. Atmosphere is non-linear system, is very sensitive to initial condition. So small change in initial condition make a big difference in our forecast or our simulations. All of these make difficulties when broadcast our results to public. Also, in science in general, we may deal with a phenomena which is stochastic random phenomena like molecular diffusion, ED diffusion. Also in COVID-19, we have random virus mutations. Maybe we deal with, as a scientist, we deal with unknown dynamics or incomplete theory, like turbulence theory is unsolved problem until now. So all of these are sources of uncertainty and they make our result not as expected from scientists. There is a domination. There is a domination of deterministic idea. The public expected that the scientist says precise and a very accurate statements. So when someone asked me about the what is about the weather forecast for tomorrow, precipitation, for example, it will rain or not? If I said it will rain by 80%, maybe some take a decision to go a journey because it doesn't go to the journey because it's very high probability. But if I said it will be about 45 or 50, about 50%, it make a annoying because it's a decision maker or public needs to help him in take a decision, or burden take the burden to in take a decision. So he said that scientists said that, so we should follow it. But actually, the decision is depend on cost benefit balance. So I'd like to share something about atmospheric science and how we deal with uncertainty, if I can. Do you see the?
Yeah.
Okay. Okay. In atmospheric science, if we represent the actual weather forecast by this blue line, this blue line actually, as labeled truth, is unknown for us. We only know observations, which is marked by blue stars. These blue stars are deviated from the actual weather, but we don't know how much it's far from the actual because we don't know the actual. What we only know observations. The observation is made at sparse network of sensors. It made by discrete intervals. All of this include uncertainty in our knowledge about actual atmosphere. Also, we can't know what is the weather condition between stations, for example. So to make a forecast, we need to fill the voids between this sensor. So we need model to fill these voids. We're using forecast models, which represented by the green line. And as you can see, is also the model give this forecast very far from the actual weather. But to make a best analysis or to best representation of the actual weather, we make a combination between the observations and the forecasts. This is represented by this square black red square red square. In both observations and model, we have uncertainty. It's represented by ellipse or circle in case of observations. Also, our analysis, it will be also have an uncertainty. We made uncertainty quantification by using Bayesian approach, Bayesian framework. The Bayesian framework give us ability to combine all available informations. Observations, their uncertainty, modeling, the uncertainty in logical framework. This actually is the best available analysis. This one is not the only is just the possible available to us, but there are many possibilities that will represent the weather situation. One of them is the actual weather. but we don't know which point in this space will represent the actual model. So we use some technique called ensemble technique. By using this technique, we can make many simulations from this area, and we go to make many forecasts. And by computing this many forecasts, we have new forecast, which is actually also deviated from the actual, but not so far. And by using new observations, we can make a new best analysis, and so on. This is cycle. Our forecast in this approach based on take all available informations, take all uncertainty included in this information, give the result in the probabilistic form, PDF in this case. But actually, this advantage or this technique only happened 3 decades ago. Before, there is only one deterministic forecast, just one simulation. If your simulation is true or false, we have no probability. So there is a misrepresentation of probability in the last. In the previously, but now we have a strong theory about how we can quantify uncertainty. The challenge related to how we communicate public, how we can interpret this concepts to public is actually related to what's the expectation of the public, what's the expectation of policymaker, and how we can change this expectation. That's what I can say in this point. Thank you.
Jaya, that's fascinating. Thank you very much. And I'd like to come back to this theme in a little while, but I just wondered if as scientists we don't need, I won't say artisans, but people who are skilled in communication, whether they're using visuals, whether they're using poetry, whether they're using whatever possible media to try to build the bridges that obviously we need to construct to the public. But I wanted to turn to Nima, please. And one question I have for you, Nima, is have scientists done enough in terms of trying to explain to the public their work, which obviously is hugely important to the public interest? Nima, please go ahead.
Thank you for the question, Peter. So I just give just a brief introduction of what specific area I work on. So I work in an area of artificial intelligence called probabilistic programming languages. And I'm sure no one in this audience have heard of it too much because it's a very niche area. What we try to do is we build a language. It is designed for scientists to explicitly state their beliefs of the world and how they believe the world will evolve. And our objective is to say, hey, as a scientist, that is where your job stops. You can state your beliefs and you can come to those beliefs with data that you have seen over decades. That's perfectly fine. But then when you are talking about interpreting the current data, you should stop at stating your explicit beliefs of the world and then present the data to it. And then let the language infrastructure go in and compute the actual uncertainty on whatever question you wish to ask from that data. The idea of such formal techniques is to kind of separate the inference procedure from the actual beliefs that a person is making for that inference. I think that is important because as scientists communicate their work is often seen as a validation of the person giving the results. Like in the COVID case, I was reading about the COVID models based on your discussion with you, Peter, earlier. And I was surprised at looking at the analysis. They were described as the US model, the UK model, and the Austrian model, and not as a model of what, not a specification of what those models believed in. I mean, I would have preferred that those models would have said, the model says that if you are among infected people, you will get infected. and everybody on Earth, they will either get infected, or they will get immune, or they will die over the course of time. And with this model, we expect these many people to die based on what we have seen, the infection rates of polio and SARS. Those are the three main assumptions in these models. And if it is communicated as those are the assumptions, and then based on the 1 week of data that we have seen of COVID transmission, or 1 month we have seen, this is the only conclusion that we can get if we believe those assumptions. I would have preferred that that is the way the models would have been presented to people. I think, like some of the previous speakers mentioned, the public is pretty smart, and they can understand. They're smart enough to. Now, of course, there are people in the audience who might believe that Narnia exists, so one has to take that with a grain of salt. In fact, coming back to that question, I think it comes down to a lot of your beliefs. Data is always interpreted with respect to your beliefs, and making those beliefs explicit is key. So I personally don't believe that Narnia exists, and I believe black holes exist. So no matter what data, I'm sure James would give me, I would always believe that the odds of CERN causing a black hole would be higher than getting to Narnia when I open my cupboard. That's again because of my beliefs. But jokes aside, I think, so coming back to your question, Peter, I think the key question is to be very upfront about your beliefs, and maybe that's a bit self-serving based on the area that I work in. But I think the motivation here is to separate inferences from beliefs, and then say, we believe this, and this is the actual observations that we have. The rest, you can just plug it into a standard framework for inference, and they will give you the same answer no matter how you do it. But if you change your beliefs, if you believe that, COVID does not depend on as a function of age, for example, it depends on the function of region of the Earth that you are in. It doesn't depend on the human physiology. It just depends which part of the world you live in. The infectious rates are going to be higher. Then your conclusion of the same data will be extremely different. If you do not believe that the spread of COVID depends smoothly as a function of how old you are, then again, that's with the same data, you can make very little conclusions. So it's very important to state your assumptions up front, because when people look at your conclusions, they often question. They say, I wonder what this model assumed, and does it really apply to me? I'm 20 years old, and most of the data they're getting is for older people. Does this really work for me? Am I equally likely to die from this based on the data that they have? Well, then this says, look, we agree that we have seen more mortality in older people, but we believe on our knowledge of human physiology that the death rate is a smooth function of age. Then the question becomes a little bit different, and then the question becomes, well, how smooth a function of age is that, right? And again, there's two ends of that spectrum, and there a scientist is coming in and putting a number, putting a function which is making that decision for you. And maybe the better thing to say is, you put your own belief in here, and here's the data, and here's a model. Put your own belief on how smooth a function that is, and you will get a different conclusion. That's
I like that idea where you make your own decision. Yes, I have a 14-year-old granddaughter who's calling me at this very moment because she can't make a decision. So no. Okay, please. What I wanted to ask all of you is, what tools do you use for communication? Can I ask you first, Angela? What? And again, if you don't have the tools, what would be the perfect tool you could find for communication? Please.
Peter, if you don't mind, I will start a little bit early, because I think listen to the others. Really, there were a lot of things that trigger some of my thoughts. And one, I think it came from you, the issue that, and I think this goes to behavioral science. And behavioral science has really changed in a way a bit. Also the idea of the rationality that we think the world has. We know physical science has the rational, but the society does not always follow rational choices. And that's why I think, and one of the things, the famous book by Kahneman, no, the Thinking Fast and Slow, that really resonated. I'm a statistician by training, but he basically says, our mind are not designed to think in statistical terms. Not even statisticians have the impetus to think statistically. So we are trained, and all of us, our science have been trained, and now it become natural to think in statistical terms, but it doesn't come naturally. And so we need to expect that the society out there doesn't have it naturally. And so I was really inspired, but also what Peter said about the James said about the story. And this is something that at least the statistics in terms of, I'm thinking about international statistics. The Secretary General of the UN has launched a new data strategy. And one of the things that it is in the data strategy is really the power of communication and the storytelling. And I think the direction that we are going now is to really trying to have this story, because again, behavioral science tells us that people think and like stories. And so how can we, turn the results that we have, the findings, into story that everybody can capture? And it's true, and I think, I remember it was Nimar that said, the public is smart. And I have to say, we are evolving. I mean, again, thinking, Saeed was talking about the weather forecast. And I have to say, my grandmother started to speak and say, oh, tomorrow there is a certain probability of that rains. I mean, when I start using statistics, she didn't even know what it meant. But, I think because if we are, if we can train also the public to deal a bit with that uncertainty, but helping them with the storyline. And then the other thing that struck me, you asked me so about the tools. So I would say thinking, but also, and I think also it came out from, I think, Nima, the idea that we need different skills. And we can't have the same skills of science, communication, and all in one person. And I think I have to confess that in my research program, I always look for, the one that does fantastic research, communicates well, writes well, good manager. And I really came to the conclusion that that is not possible. So what I'm seeing now in my research team is, and what I'm looking is to acquire different skills. So acquire the good researcher, and then to acquire somebody. And then I guess it goes a little bit more in the direction what Nima is saying, that you try, and then at a certain point the science stops and then starts. But I want to conclude also another thing that triggered my mind from Nima. That you're saying, and it's, I think the myth of the scientific method, and I think at least I've grown up with, I come from the University Padova, where there was we started looking at the desk of Galileo Galilei. So the idea that the scientific method, that's how, you've grown, and there is the myth that there is this scientificity across the whole research. But I see this challenge, first of all, the understanding, and I think as Nima was saying, it doesn't exist, the researcher. As researcher, we make decisions every day. We make a decision on whether research this or that. We make a decision where to put funding here and there. So in a way, this absolute impartiality does not exist. And indeed, we need to be transparent, but to a certain point. But what I see that taking this also, I personally think maybe too far. I have started hearing of subjective research. So in a way that, and again, I bring, I'm sorry, the example of the drugs, because that's where I think this unbiased mostly come. And I started to hear, researchers, they say, well, we're actually not interested in the scientific research. We are interested in research where you have a stake in the research, because if you have a stake in research, you can understand better the topic. So I just leave you with that thing. To me, as a science, maybe old-fashioned, I don't know, to me is going too far. But then I leave it to you also as a thought.
Thank you, Angela. James, I'm going to turn to you, please. because I'm very interested in. Okay, we talked about Narnia, we've talked about wardrobes. How do you maintain a dialogue? Okay, you know, you had a novel idea for beginning it, but then how do you maintain it? How do you ensure that the people you're talking to understand what you're talking about? Over to you, sir.
Well, before I answer the question, let me just say we have an approach that we take. How successful it is, I really don't know, actually. I mean, we took a decision a long time ago that there were things coming out about CERN that were so far from perceptions that were so far from reality that we realized we've got to be part of this conversation. We've got to be ahead of this conversation. We've got to be leading the dialogue about CERN. We've got to be trustworthy. We've got to be transparent. We've got to be honest about it. And I read something in the Guardian newspaper last weekend, actually, about what happened to AstraZeneca. And one of the chief researchers on that said, we didn't get ahead of the dialogue. And that really resonated with me. I mean, they let other people control the narrative about them. So that's what we decided to do. And this was in the early 2000s. You know, the first thing that looked like it could be very damaging to us was Dan Brown's book, Angels and Demons, which was published in 2000. It flopped, but when his next novel, Da Vinci Code, started selling, we read it, we knew what was coming, and we, to the great credit of our Director General, he let us put it up as the first thing on our webpage was a picture of a Lockheed X-33 space plane that we used to hop across the Atlantic in 25 minutes, or do we? And we just did a true and false about it, and we learned from that people really liked it. They got really engaged. It was a real opportunity for us to talk about the science that we do. And then a few years later, social media came along, and when we realized that there wasn't a rule book, we just jumped into social media and we started talking to people, and we found that there were all kinds of people following us. So there were people, you know, in popular culture who were following us. So social media has been really very good for us as well. But we're always there, and we're commenting on things. We're talking about how science is done, and I think that people are engaging with that. We're very successful. I mean, on Twitter now, I think we've got 2.5 million followers or something, which is a lot. But in terms of population of the planet, it's still a very small number. We've got to realize the size of the audiences we're engaging with. So, you know, we're a big organization. We've always taken our communication, public engagement very seriously. So within the communication team, of course, we do all the standard corporate communication functions, but we have exhibition centers. We do guided tours of the facility, not at the moment, very few, but typically we have about 150,000 people a year we show around the laboratory. We have educational programs. We have a team of people doing science education research to see what works, publishing in peer-reviewed journals and so on. And I think one of the things that, if I wanted to highlight a single thing that I really do like and I really think is important, and I hope we can spread further, is that we developed 10 years ago, we're celebrating its 10th anniversary this year, a scientific program for primary schools, which we developed with the French Éducation Nationale and the Department of Public Instruction in the Canton of Geneva. And it's very simple. It basically involves that every year about 150 primary schools in our region get a box about this size, sealed cardboard box, and it's got stuff inside it. The kids can't open it, but they've got to work out what's inside by thinking scientifically. So they've got to accumulate evidence about it, and they work with the University of Geneva. If they say, can we have an X-ray? Some of them do, then they'll get an X-ray and things like this. And it's brilliant. You see these children behaving scientifically, thinking in a rational, evidence-based way. And I think that's where we've got to go, actually. I think that you've got to, I wouldn't go as far as saying you've got to teach children to think rationally and scientifically, because children do, in my experience. At some point, they stop. So you've got to keep them thinking rationally and scientifically as they go forward. So I think those kind of programs are important. And if I could just pick up on a couple of things that have come up. I mean, Nima, you were talking about the nature of science. It's very interesting, actually, to me, that from being a physics student, where, you know, when I was taught, you knew the result of the experiments you were doing, so you made sure you got the right experiment, right? That was ridiculous things that used to happen in physics education at universities when I was there. But now, you know, even at CERN, which is you would think that, you know, the kind of physics that we're doing is you know, very objective, but it just isn't. So there's huge efforts are made to stop human beings interfering with the analysis at any point, and to stop different teams doing similar analysis from talking to each other or seeing what they're doing, because we're so good at skewing the results. So So now you'll have analyses that are designed, and they're designed to be as impartial as you can get them, and then they go into a black box, they run, and at some point you think, well, there's enough data in there now that we should have a result, and you look inside and you find out what the result is. So that's very, very interesting. Even in particle physics, that's a feature. And the final thing, you know, I hear what you were saying about Narnia and black holes, but you know, I can't tell you that the probability of opening your wardrobe and finding Narnia is 0. That's not a scientifically true statement. And I can't tell you either that the next pair of protons that collide in the LHC won't create a black hole and destroy the planet either. I can just tell you that it's extraordinarily improbable in both cases, right? I mean, that's the nature of science. That's how science works. And I think that we as science communicators have got to try and get that kind of rationale out there. So yeah, I'll leave it at that for now.
James, fascinating. Thank you. Syed, can I just turn to you, because James brought up this whole issue of public education, and I think it's very important. And I just wondered what your thoughts on reaching out to younger people are in the community, how to engage them. And I'll also return to the question of tools, and I'm interested, are you using social media? Do you have people working with you who can help you use social media? So over to you, please.
Okay. First, I'd like to emphasize on the point referred by Angela about the mind of a human being is not capable by its nature to dealing with uncertainty. In the ancient human evolved in the forest, and has any hesitation against in the face of predators, it means this. So dealing with uncertainty in this environment is not safe. So the people need to be sure about their decisions. So we need to make to deal with uncertainty needs training, needs learning. So the educations need to include the uncertainty in all level of educations. In my university, I don't take any course about uncertainty. Actually, I learned about chaos theory, about nonlinear dynamic and complexity by myself, not included in the undergraduate courses. But because the graduate course needs to be took examples about linears, very simplified example to be clear for students. But the real life problem is more complicated, and needs upgrade our educations to deal with this actual problem, what we face when we go to actual work. The social media may play a good role in this, in spreading a new idea about nonlinearity, about complex systems. But in the same times, it play some bad rules about fake news, fake ideas. So it's danger for me. I don't use social media in this regard, but I emphasize about training, professional training, and during education also may help make the make us a professional and a scientist and the public deal with uncertainty in a good way. This is my idea about this point.
Thank you, Syed. Dima, you invented your Bayesian machine learning tool. First of all, I don't think the public knows what Bayesian is all about, because it refers, of course, to statistics, and just going back to what we've been saying, that our poor little human brains are not very good with statistics. Anyway, how do you deal with you know, in your profession, how do you deal with communicating these issues? And what examples do you have of success that, you know, what's worked?
First of all, I would point out that I don't do a very good job of communicating uncertainty. I certainly don't have some of the skills that that Angela referred, and the ideal scientist doesn't really exist. So yes, it is a very big problem communicating Bayesian methods. But I would like to say that we all use Bayesian methods. I mean, talking about the Higgs boson particle, I mean, physicists have believed that it existed for a long time, for decades, and they have been looking for evidence for it, right? They have built a models that said, we believe this particle exists, and if it exists, we expect to see this data in some observation, and they run experiments. And for decades, they have been trying that, and in 2012, they announced that. But there is and in everything that we do, we believe certain things, and then we look for data to confirm or deny the beliefs. And again, going back to this question of someone said that people stop being rational at some point. Children are rational. I don't think they stop being rational. I believe that again, I believe that they change. There's a divergence in beliefs of people as they grow older. And if we understand the beliefs, they are acting perfectly rationally. Everyone acts perfectly rationally. It's just that their beliefs appear irrational to other people. And what we do in Bayesian reasoning is try to say, let's just try to formalize this notion of belief. What is it that you believe before coming into a discussion? What is it you believe about the world? And how do you believe the world evolves as you see? And then that constrains what you can then conclude from the data that you have seen. That's what Bayesian reasoning is all about. It is the very essence of rationality, of human rationality, which is again based on what you beliefs you come in. Every human is perfectly rational if you examine their beliefs about the world. I mean, there are people who believe that the election was stolen in the US, right? And they interpret the data extremely differently because they have a worldview of how the world would evolve if the election was stolen. And the data that they see, supports their worldview, and then they are able to sustain that belief. Now, other people can say this is completely irrational, but if you go to their beliefs, it is. So again, I'm getting into a little bit of a tricky subject. But what we do in Bayesian inference is say, like, we are not the arbiters of your belief. We are the arbiters of reasoning under beliefs, and so that's all we do. So coming back to this notion of where I've succeeded and failed. So I've worked for CTBTO for the last 10, 12 years now, and trying to use Bayesian methods to identify the existence of seismic events. And the first thing I did when I started working was talking to seismologists and trying to understand what their beliefs about the Earth was, what their beliefs about where seismic events take place, how they propagate. And then we wrote those down into equations, and we said, does these equations resonate with how you believe about the world, given your body of data from decades of work? And then we said, okay, once we write down these beliefs, then this is the conclusion we get. I thought that was pretty rational and pretty simple. It wasn't. It opened up a can of worms where people said, these beliefs that you have written down, these are biases, and your whole work is biased. The conclusions are biased. And that got me thinking, I did not invent these beliefs. These are beliefs that seismologists have, that, there are tectonic plates and seismic events tend to take place, on the ring of fire. We've heard that in school, and those are pretty standard beliefs that all we did is put that explicitly in a model, and we just said, let the model do the reasoning given these beliefs. And then the question is, well, you're introducing a bias. Places that are more tectonically active, you're more likely to place an event there. Is that produces a bias for something like a CTBT, which is supposed to be an international treaty, neutral for all countries? Are we introducing a bias? again, I'm not very well qualified to talk to questions of international diplomacy. I can just look at the scientific beliefs and encode it. But then it took very many years of discussion on this one simple topic. And there were in fact 5 or 6 such beliefs that, were raised questions. But I think eventually it came down to just talking about the effects of those beliefs. What is the effect of believing certain things? How does that influence the data that we see? In the case of tectonically active parts of the Earth, what that means is that that we are able to claim a seismic event occurs in a tectonically active region with less evidence than we are able to claim the same thing for a less tectonically active region. And that is all that comes down to. And the difference of how much less evidence you want is just, again, a matter of the prior data that we have encapsulated with some model. So I think, again, it's a lot of learning. I'm not in communications. I'm not a social scientist. I don't really understand how people think and how they react to data. So this has been a learning experience for me. But eventually, what I have found is that if we engage, like James talked a lot about engaging with the detractors, it is and just follow through the reasoning of the detractors and just take it to the conclusion and say, okay, assume that this does introduce a bias. What does that bias mean? And what is the effect of that bias? And is this an irrational bias? Because what we were able to show is that the existing methodology had the same bias, except that it was not explicitly stated. So then the question really does become, is it better to have an implicit bias deep down hidden somewhere in the equations of your inference method that nobody really understands, than to state them explicitly so that later future generations can maybe question that in the light of the bias? Yeah, I'll leave it at that.
Thank you, Nima. Running out of time. This is horrible. I was really enjoying. We're having a great conversation. I've got a whole kit of questions. But look quickly, because I'm gonna have a sort of a last few minutes round table. I was an environmental reporter. I started writing about climate change in the 80s, for God's sake. I'm sorry. I'm Canadian. You know what's happened just down the road from where I used to live in British Columbia in Lytton. Temperatures of nearly 50 degrees Celsius, and now the poor little village is burned to the ground. And yet you're still, and yet people are still saying that the issue of the scientific evidence of climate change is too unsettled to take action, which to my mind sums up the kind of ultimate consequence of uncertainty. And I just would like all of you to in a minute or two just give me your views. How do we address this uncertain issue that if we don't address it seems likely to result in terrible consequences for all of us? Angela, do you want to just kick this off? And please, can you keep your comments fairly short? I'm sorry.
No, I think I just in a minute I will just conclude that just to say, I think we started with say how we communicate uncertainty. I think after all of this discussion, I think as a scientist, we need to find the right balance between, of course, transparency and understand and push everybody to understand the uncertainty, but to the point that we don't place uncertainty to the point that the science is under question, that we don't push it too far. And as we see now also with vaccines and everything, that the people question the idea that we have common facts to share, as not that everybody has his own facts, because everyone has his own beliefs. So that's my last thought.
Thank you so much, Angela. James, can I ask you for your final comments, please?
I'll answer the question you posed, Peter. Actually, and I think that in my experience, some elements of the media do have a lot to answer for, in that they have this principle that they have to show balance, and they show balance when there isn't very often. So in the climate debate, that does certainly seem to be the case for me, and it's something I know that's been discussed at science journalism conferences. Should science correspondents talk about, this was actually the name of a session at a conference a couple of years ago in San Francisco, 2017, actually, more than a couple. But should science journalists talk about global warming when there is an extreme climate event? And that's being debated in science journalist circles, because you can't tie any individual event to global warming. So it's being debated there. And I think, you know, probably one of the most visually striking things, and one of the best sources of journalism, is actually The Daily Show, because I remember John Oliver doing this. Let's show balance on the climate debate. So he got in the skeptic, and then on the other side, he got 100 people coming in to represent the other side of the argument, because that's what it really is. But a lot of the time, you'll see one on one side and one on the other. So that's misleading for people who are not used to judging evidence and making decisions in that way. So my final word is, I think the most important thing that we can do, people like me as science communicators, is actually get across the message of the power of evidence-based decision making and how important that is in pretty much everything we do these days. So that's where I started, and that's where I'll finish. Yeah.
James, thank you very much. Syed, can we get a few comments from you, please? I'm sorry, the time is limited.
Okay, climate change is a good chance, or debate about climate change is a good chance to test our communication uncertainty, because these debates deal with time scales not so far or not so urgent, but it takes many years, and we can't talk to public about the, if we don't take action in nowadays, we will face we can't solve the problem in the futures. So this debate, and it's a chance to learn non-specialized people about how science works. Because you as a scientist should provide the evidence, their methodology to conclude, how these models, what is the accuracy of the models. All this subject is good chance to what's called make a broadcast about uncertainty, or how we can deal with it. So I think subjects like climate change and many other subjects related to risk is good chance to make it our training to non-specialized people to think about uncertainty, or make a good communication in this point. Thank you.
Syed, very important points. Thank you very much. Nima, can I ask for your closing comments, please, and perhaps respond to the question?
Thank you. I think I don't think self-righteousness will convince anybody. I think we should entertain all hypotheses, and I think we should just work it through. We should put enough effort into considering alternate hypotheses of climate change, and describe the likelihood of those alternate hypotheses explaining our observations, rather than just dismissing it offhand. I think that would do a much better job if the public sees that we are investing in studying these alternate hypotheses, like, you know, it was pointed out, we should engage. Then I think we have a much better chance of convincing people than believing something and then going that this data just proves beyond doubt that this is the only conclusion.
Thank you, Nima. I agree 100%. It's not a universal language, but we tend to talk over people's heads, and I think that's awful. We're at the end. I'm sorry. Jill, Mario, did you have a final few words to say? I just want to thank everybody for putting up with me, and appreciated all your comments, and I found it, you know, fascinating. It was a great conversation. Thank you. Jill, Mario.
Thank you very much, Peter. That was really fascinating. As a former journalist myself, and now having crossed the fence to being a communicator and in the science field, not being a scientist myself, it's really given me a lot of food for thought, not only for my own personal decision making, but also our communication at CTBTO. So thank you so much to everybody, to Peter for a great moderating job, to Angela, James, Syed and Nima. Thank you very much indeed. Mario?
Yes, thank you, Jill. Yes, thank you, Peter. Thank you, James, Angela, Syed, and Nima. It's been a wonderful, very interesting, fascinating discussion. I couldn't agree more with everything that's been said as a scientist and not as a communicator. But yes, the key takeaway point for me here is we should not talk over people's heads. We should not patronize people. And I fully agree with what Nima said. It is very important to entertain all the hypotheses and then go about it and communicate how you go about it and analyze it and develop the different scenarios in a credible way. Because if we look back at the present situation, at the COVID crisis and at the present situation, one potential problem is that things are presented in a one-sided way, and that creates distrust on the other side, to the point that even when you present simple statistics of numbers of this versus numbers of that, it's questioned even what if those numbers that you're presenting are not wrong or biased by your own preconception. So it is very important to discuss and take seriously all arguments and all counter arguments, and then just work through the math basically in a way that can be understood and establish confidence. And that's when there's confidence and trust, then the scientists, I think, will be understood better than they are now, because I think now often in the debate, scientists are not well understood. So thank you very much.